Saxon Algebra 2, Lesson 100. Congratulations, ladies. We made it to the triple digits, 100 lessons of math. We have endured/celebrated. If I was with you right now, I would give you a pile of 100 Skittles for you to enjoy as we work on this lesson. Just pretend for now, and I'll get them to you later. Okay, lesson 100 is going to make you feel smart. The topic is graphs of parabolas. Now, what the heck is a parabola? I'm going to show you. We're going to talk first about how, and we'll get into the algebra portion of this. For now, I'm just going to show you an equation of what would yield a parabola. It will look like this. It will have a quantity, x plus or minus some number, in parentheses, that will be squared, and then there will be a plus or a minus hanging off the back end. I'm going to put this in here just to show you. There would be either a plus or a minus in front of the quantity. If it's positive, you probably won't see the actual positive sign, but if it's negative, you'd have a negative sign. These numbers and signs give us clues as to how to graph the parabola that this represents. So we're going to do that right now, and I'm going to help you through the clues. I'm going to draw this lower so that we have plenty of room up here. The first thing that we look at when we graph a parabola is this package, the sign and the number that are inside the parentheses. This is called the axis of symmetry. When I draw it, you'll understand, so just give me a second. And we write it as x equals positive 4. Notice what I did. I flipped the sign when I took that number. What that tells us, we count out 4, we go to 4 on the x-axis right there, right? 1, 2, 3, 4. And we draw a dotted line. It'll always be up and down because our parabolas are either going to go up or they're going to go down. We, in this course, we're never going to draw side-to-side parabolas or crazy tilted ones. We're not going to do this. Ours are always going to be up or down. And just to draw a little mini version here, of symmetry, our parabolas will be centered. They might be fatter, they might be skinnier. That one's not as perfect. But this axis of symmetry will always go right through the middle of our parabola. So that's what's really useful about it, is it's kind of like the mirror where we image the matching halves. Okay, so that's always the first thing we graph, is the axis of symmetry with a dotted line. The second thing, the second step in our graphing is what we call the vertex. And that is this number and this sign. We write it as y equals negative 3. Notice with the vertex, the sign stays the same. With the axis of symmetry, the sign changes. Very confusing, but we'll get used to it. Okay, the vertex is either the low point of a parabola that goes up or the high point of a parabola that goes down. And we mark it with a dot, okay? This we mark with a dotted line. This we mark with a single dot. And in ours, it's y equals minus 3, so we go here. This is the x-axis. This is the y, just to remind you. Y equals negative 3. 1, 2, 3. So right here is going to be either the bottom of our up-facing parabola or the top of our down-facing. We don't know which it is yet, but that information is contained right here. And this is step number 3, to determine whether we're up or down facing. If it's positive, that means our parabola opens up. If it's negative, That means our parabola opens down. That's what we mean by opens up or down. Kind of self-explanatory. In our example, it was positive. So that means our parabola opens up. Now, when I go to graph it, I'm going to start slow. What I'm going to do is I'm only going to draw little curvy bits that go up one and over one, up one and over one on both sides. Right? So I'm just going to go like this. That I can always draw as my starting point. Now we have to figure out how skinny or wide our parabola is. We can always start with 1 unit over. But now we're going to, for step 4, we're going to plot, and we're going to calculate 2 more points. Or I'll just say 2 points. Okay? Now, here's one thing that's really cool about this. Never mind, I'm going to say that and tell you that in a minute. Here's the way we calculate the 2 points. X and Y, and we use this same expression, just like we have for other things. X minus 4 squared minus 3. I copy exactly what is on the right-hand side of the equation. This one was positive, right? This was just to remind us there were options. This is the actual sign for my equation. It's positive. It was negative. I'd have to put the negative there. So I'm going to choose my point here, 2 units to the left or right of the axis of symmetry. Just like all words in math, this makes it sound way harder than it is. Here's our axis of symmetry. We've already plotted 1 point to the left or right, so now we want to go 2 points to the left or right. So when I choose my x value, this is 4, so I want to choose either 6 or 2. 2 units to the left or the right of the axis of symmetry. So I'm going to choose the bigger number, 6. So I'm going to choose let x equals 6. Now I'm going to do my calculation, 6 minus 4, quantity squared minus 3. 6 minus 4 is 2, 2 squared is 4, 4 minus 3 is 1. So that tells me that I can plot 0.61, and that will also be on my curve. So here's 6, and there's 1. So that tells me my parabola is going like that. I don't have to find more points up here. This is fine. It gives me enough information about the shape of my curve that for our purposes, we're good. Now, I need to have a point on this side. And what I'm going to tell you is that because we know our parabola is going to be perfectly symmetrical on this line, I can take this point and simply copy it in the mirror, so to speak, on this side, right? I know it's going to be at the same level. It's 2 units to the right, so I can plot a point 2 units to the left. I could have calculated this point first and then just sketched this one in, but these two will always be the same because our parabola is perfectly symmetrical. Just to prove it to you though, I'm going to calculate it. This one is at 2, right? X equals 2. And that's 2 units to the left of our axis of symmetry. 2 minus 4 squared minus 3. Now, here's where the magic comes in. This one came out to be 2 first, and then when we squared it, we got 4. This one is going to come out to be minus 2 first, but then when we square it, we're going to get the same 4. There's the symmetry in the numbers that we see in the picture. 4 minus 3 is 1. So now I have plotted this point 2, 1, and you can see that we don't have to do both calculations. If we do one or the other, we'll be able to get the other point. So this is my completed parabola. It is the sketch of y equals quantity x minus 4 squared minus 3. That's the name of that parabola. Cool? So 4 steps. 1, 2, 3, 4. I will use this 4-step process as we go on and graph more. Okay. Now that we have a clue 4 clues actually, about how to graph them. We're going to talk a little bit more about the algebra. Example 100.2. That was 100.1. That's not true. This is 100.1. Anything. I didn't. Okay, ready? Y equals x squared minus 4x plus 2. Well, wait a minute. This doesn't look right, does it? We need to have the parentheses and the square. Not just, this is just like a quadratic equation. Aha! So now we have to work on the algebra to get the equation into the proper form for graphing. And what we have to do is complete the square. Oh, remember doing that? We did that before we came across the man-eating dragon as the easy way to factor our trinomials that we couldn't just do with our eyeballs. So we have to complete the square, and we have to complete the square with just 1/2 of the equation, right? We can't get rid of our y. So what that means is that we have to employ a few tricks. So I'm going to show you what they are. First thing, we're going to put parentheses around what we would consider the a term and the b term. So we're going to put x squared minus 4x inside of parentheses. And remember how I always said we were kicking the c term to the curb? And I said there was a reason why we say that instead of swimming it to the other side. Now's the time. 2 does not get to go inside the parentheses. We're kicking it to the curb in this context by keeping it on the outside of the parentheses. So that is the second part of this step. Kick C to the curb. There it is, curb. By keeping him outside of the parentheses, okay? Now, 2, magic number, that works exactly the same. Our magic number will be minus 4. We take the b value, we divide it by 2, and we square it. I calculate this, that would be -2, right? That simplifies. I draw an arrow to that, we're going to need that later. -2 squared equals +4. So, I'm going to add 4 right there. Now, what we did before was we would add 4 to both sides to keep the equation in balance. But in this context, we're doing all of our work on one side. What I have to do when I add the 4 here, I'm a little crowded here, I have to subtract it out here in the curve. These two balance each other and keep our equation in sync. That's how we do with our magic number. Instead of adding it to both sides, add, then subtract. That's what I mean by this process. And that is tricky and you'll forget it. And if you ever get one of these problems wrong, go back and look because that's probably where it is. Okay, now we're ready to collapse this into its squared process. We know the number here is what's going to go in here. -2. We double check it. It should multiply to this. Yes, -2 times -2 equals +4. And it should add to this. -2 minus 2 is -4. So this checks out. Now we simplify this. +2 minus 4 gives us -2. All right, and so this, we're saying, is what we want to graph for our parabola. This is the cleaned up equation. I do recommend you check your solutions manual here and make sure that your equation looks good before you dive into graphing it, okay? So that's my advice to you, is check the solution at this point. But I already did, and now we're ready to graph. So we have to remember our four steps. First comes this 1, it's the axis of symmetry. I'll just abbreviate it because I don't want to get into my steps over here. Sorry, I'm finishing my step list because I left off after the magic number. But I think you're familiar with enough that we just finish algebra, use algebra to finish that up. Okay, so the first thing we did was we found our axis of symmetry. This is the one where the sign flips, so it's x equals positive 2 in this case. So here, oh, I got really crooked. Let's call that 0, that'll be 1, that'll be 2. Pretend that y-axis is perfect. There's my axis of symmetry, y equals 2. Remember, axis of symmetry will always be up and down like that. 2, my vertex. You don't have to play games with the sign. That's y equals negative 2. That tells us where to put the dot. Y equals negative 2, so we're down here. That means either our parabola is going to go up, and that's the low point. It's like the turning point of the parabola, either down or up. We don't know yet, so we go and look at the sign. There is no sign. This is our step number 2. This is our step number 3. And this tells us that it opens up. Okay? I can go 1 unit on each side up, but then I have to stop and do my fourth one, which is to calculate a point. This expression, x minus 2 quantity squared minus 2, that's how I'm going to get from x to y. I choose my x value by looking at my axis of symmetry and saying 2 units to the left or 2 units to the right. Those points will be the same. I can use either one. Let's use the 0. 1, 2. Okay, so now my calculation looks like this. 0 minus 2 quantity squared minus 2. This is minus 2, the value of that. So then when I square it, I get positive 4 minus 2, that is 2. That's a lot of 2's. So I know that the point 0, 2 will be on my parabola, it will be on my curve. So I go to x equals 0 and y equals 2. And then I can go 2 units in the other direction and put my other point in, and that would be the same as if I chose 1, 2, 3, 4. And I can see in my head 4 minus 2, if I did this, if I did 4 minus 2 squared minus 2, well that would be 2, squared it would be 4, 4 minus 2 is also 2. You don't have to do the second one, I'm just proving to you that it will always work. And now we can draw the rest of our curve. And the name of that curve is y equals quantity x minus 2 squared minus 2. All right, that is the full scope of the work that we'll be doing. We'll be given a trinomial that is not in the proper presentation. We'll use a slightly customized version of completing the square to get it the way we want. We'll check the solution to make sure our equation is good. And then we'll use the 4 points, 1, 2, 3, 4, or I should say 4 clues. 4 clues to graph. Okay? Cool. Let's do another one. And there's one more little wrinkle that, well, it's another wrinkle. What can I say? 100.2. I can feel myself drifting crooked in the frame. Okay, this time we have y equals minus x squared plus 2x plus 2. Okay, there's the drama right there. We do not want a minus sign in front of our x squared. That's going to mess up our completing the square situation. So we have to get rid of that. And here's what we're going to do. Have you ever played hot potato? It's that game where you take usually a ball, not a literal hot potato, but you pretend it's hot and you pass it back and forth with another person quickly because you want to get rid of it. You don't want to be the one holding the hot potato. This minus sign is the hot potato. So what we want to do is we want to toss it over to the other side so that we can quickly complete the square, and then he's going to toss it back to our side. So let's that we toss it is by dividing by -1, both sides. This is not an inequality, so we don't have to worry about that weirdness. Our brains are still thinking about that. But what that does is the hot potato minus sign to the y, and it frees up a minus sign from every single one of these signs. So it not only fixes this first one, yay, that looks better, but it changes this one and that one. Okay? So the hot potato's gone from everybody, not just him. Now, he's going to hold it for a second, though. He's not going to throw it right back. So now we can complete the square just as we otherwise would. So we set up the parentheses with those guys inside, but we kick that -2 to the curve. We calculate our magic number. It's -2 divided by 2, which is -1. We draw an arrow to that. It's squared. -1 squared equals +1. All right? So we're going to add 1 here, and then we have to subtract 1 there in order to keep these two in balance. Right? That's how we keep harmony in the galaxy. Okay, now we're ready to write this in our term. I'm going to squish it over a little bit. It'll be x. There's the value that goes in there. We can check it. These two should multiply times itself to get +1. That's true. -1 times -1 is +1. And it should add to this one. -1 minus 1 is -2. Check. And then we can combine these guys out here to -3. All right? Cool. Now, hot potato time. Now that we've got this cleaned up, he is going to send, this y is going to send the minus sign back to us. And what I'm going to do, last time I just drew one big line. I'll do that again this time. There's multiple ways to look at it, but this is fine. This cancels, and now our y is clean again. Here's what this minus sign does. It comes up in front of the quantity. Notice that it doesn't change the signs of what's inside the quantity. We're just keeping it right out here. We could distribute it if we wanted to, but we don't want to. And then, so it comes up over here, and then we have to do it on this term too, and here it will actually change it to +3. So this term gets a minus sign in front of it. This term, we actually change the sign in front of the number. Now we're in graphable format. You would check the solution here. Let me double check. Yep, that's correct. Now we're ready to use this for our graphing. Let's see if I can make my y-axis better. Yay, I like it so much better this time. And x is pretty good too. If it helps you to label those, by all means label them. Okay, so now we look for our clues. The first one is here. This is the axis of symmetry, and we know that x equals +1. The sign changes. So that's right here. That's x equals 1. I draw the dotted line, always straight up and down. Okay, that's the first clue. Second clue is right here. And this is the dot, the vertex, the turning point to go either up or down, though we don't know yet. It's at y equals 3. Remember, the sign changes the same. The sign doesn't change for the y value. It changes for the x, it doesn't for the y. Y equals 3, 1, 2, 3, so we can put a dot on our axis of symmetry. And we know that's the turning point. It will either go up or it will go down. Where do we find that information? Right here. That's our third clue. And this is a minus sign. And it was way back here. Remember that we talked about how the minus sign tells us that it opens down. So we know that it's going to go down from here. We can draw the first unit of the curve, but now we're going to do step 4. We're going to calculate just one point. I'm giving myself lots of working room. This will be our x, this will be our y, and we'll use this expression. It will be minus x minus 1 squared plus 3. I wrote it in 2 lines just because I'm a little crowded. But this expression is what I wrote here. Okay, how do we choose a good x value? Well, we go 2 units over from our axis of symmetry to the right or the left, it doesn't matter. Let's be scary and give ourselves that negative number. So 2 units to the left would be 0 and then negative 1, right? So I'll use negative 1 as our value. I could just as easily use, this is 1, so this would be 2, 3. 3 would work just as well, but I'm going to use negative 1. So I plug it in. I cover up this to do this calculation first. I'll put the minus sign back on. Negative 1 minus 1 is negative 2. Negative 2 squared is 4. Negative 4 plus 3 equals negative 1. That tells us is that negative 1 is another point on our parabola, and we can go 2 units over on the other side of the axis of symmetry to get our second point. So now I can just curve, and there is our beautiful parabola. Graphed with beauty and care. Okay? One more example. This one, 100.3, will be another example like this where we have to deal with the minus sign. So it gives us practice in that. It's no harder. Example 100.3. And complete the square to graph. Y equals minus x squared minus 6x minus 8. Okay, we see the minus sign here. We say, okay, John, have it your way. Let's play hot potato. Divide everybody by 1 to pass the minus sign over to this guy. He's got it now. And all of these signs change because we're dividing by minus 1. X squared plus 6x plus 8. Okay, now we're ready to complete this square. We start by putting these guys into the cool parenthesis club, and poor 8 just gets shoved over to the side. Kick to the curb. Magic number. 6 divided by 2, quantity squared. This would be 3. That's the number we'll need later. 3 squared equals 9. Okay, if we're going to add 9 here, then we have to subtract 9 there. That keeps the universe in balance. Okay, now we can simplify this. Minus y equals x. And we know this number is going to be what goes inside the parentheses. We double check. 3 times 3 is 9. 3 plus 3 is 6. Good, it works. And then this reduces to minus 1. Okay. We're almost there. We've got our square completed, but we've got a hot potato, that minus sign, back again. This time I'm going to do it separately because I think it illustrates it a little more clearly what we're trying to do. This becomes y is positive. This minus sign we're just going to put up in front. This minus sign will change that sign above it directly. All right, we stop and check to make sure that this is the correct solution. It is. Now we're ready to graph. Y-axis, x-axis. First clue, axis of symmetry. X equals -3. 1, 2, 3, right there. Vertex, turning point. Y equals +1. Y equals +1, that will be right there. Does it go up or down? Third clue. Down. I only draw the first unit of it going down. Fourth clue, calculate 2 points. Spoilers, we only actually have to calculate 1. X, Y, we copy this into our box, here our function box, +1. And then we choose an X value that is 2 units from the axis of symmetry. So let's see, let's go with, let's see, this is -3, -4, -5. Will it X equal -5? I write it into this function, we could call it, this expression. And now I do the calculation. I cover that up. -5 plus 3 is -2. -2 squared is 4. This makes it -4. -4 plus 1 gives me -3. So my point is -5, 1, 2, 3, 4, 5, -3, 1, 2, 3. And if 2 units over that way, 2 units over that way, I can make my symmetrical point and finish drawing my parabola. And this is the name of that parabola. Yay, we got it right. You guys, this will make you feel smart. I hope it already does make you feel smart. Step by step, using the clues, calculating the second set of points, you can do this and you're going to feel like a genius. Don't forget about the hot potato and the tricky rules around that. Don't forget about the weird way that we kick this C value to the curb by putting him out of the parentheses. All right? And then this, I've talked about before, when you add your magic number inside the parentheses, you subtract it on the outside. That's one super easy to forget. All right, lesson 100 is now complete. Pat yourself on the back. Job well done. See you for 101.